Bless you. So problem number 7, this is from the handout on section 5.2. Okay, because I've asked you to work on those problems 7, 8, 9, and 10. So let me make sure that you get those right. In problem number 7, we have negative tangent square of theta or of x. I love theta. Have you noticed that? Just everything I want to put theta on it. Okay, so tangent square of x, and then plus secant square of x, and that is supposed to be equals to secant square of x, and then cosine square of x. Did any of you complete that proof for homework? So you can guide me through that? Yes. What do you do, Brenda, to do this problem? Okay, negative sine square of x over cosine square of x. And then? Cosine square of x. Great. Okay. Then we have the same thing, right? So we can just put it together, as one fraction. Great. Awesome, Brenda. So this is negative sine square of x plus 1 all over cosine squared of x. What else after that? Mm-hmm. 1 minus sine square of x. You just rewrite it, right? In the form that you have this formula on the Pythagorean identities, right? So, and what is that equals to? What is all of this? 1 minus sine square of x on your Pythagorean identity paper. It's equals to cosine square? Okay. So that is equals to cosine square of x. Okay. This is leading me to a 1. Is that what it is? No, right? Okay, but what else after that? Mm-hmm. So on the right side, okay, what do I do on the right side? Do I rewrite that? Okay, as 1 over what? Cosine square of x, okay. And that is multiplied by cosine square of x, okay. It's equals to cosine square of x over cosine square of x, okay. And that's just 1. So, oh, it's the same thing as the left side. That is right. So, but isn't it that equal to 1? Right? So that is equals to 1. This is equals to 1. This is equals to 1. And over here, the left side is going to be equals to 1. So there's the proof that both sides are equal to each other. Good job, Brenda. Way to go. Now, problem number 8. Number 8, we have sine cube of x cosine square of x, and that is supposed to be equal to sine of x parentheses cosine square of x, and then minus cosine to the 4th degree of x. Okay, interesting. Did any of you attempt this problem? Tony, were you able to get to that problem number 8? No? Okay. The right side? Okay. Sine of x? Okay. Cosine square? parentheses 1 minus cosine square of x. Okay, so you factored out. You factored out one of the cosine square of x. And when you distribute, you get these two things. Okay, great. I see that. Awesome. Okay. And that would lead you to simplify it a little bit, right? What did you simplify? Uh-huh. Okay, so let me rewrite it. Sine of x equals cosine square of x. And what is all of this here? All of this, if you look at the identity formula chart, that is just sine square of x. Great. So that is just sine square of x. Okay. When you distribute, would you get the left side? Yes. Okay, great. So when you distribute, you'll have sine of, well, cube, right? Because this is not a plus or minus in the middle. You just bring this down and you actually multiply sine times sine square, and that gives you sine cube of x. And then you just rewrite cosine square of x. Because it's not a binomial, you don't distribute. It's just the sign with the sign, and it's sine to the third power. And that is the same thing as what you have on the left side. Good job, Brenda. Okay. In problem number 9, we have 1 minus 2 secant of x minus 3 secant square of x. All of that is over negative tangent square of x. And that is supposed to be equal to 1 minus 3 secant of x divided by 1 minus secant of x. Okay. Did any of you approach this problem, number 9? You approach this one. Okay, you said open parentheses 1 minus 3 secant of x close parentheses times 1 plus secant of x. Okay, close parentheses. Okay. I'm pretty sure many of you are like, what? What is she getting that from, right? So would you explain to us how'd you get that?
I just looking for the multiply giving the
Right, so you're just factoring, right? And you factoring because you know that this is a square, this is a square, 1 times 1 is just 1. So this could come from a difference of squares, or you can multiply 2 binomials, and that would give you that. Now, let's check to see if that would be the original. Let's see. 1 times 1 would be the 1, right? That was a long process, but it was mainly algebra. Yeah. Okay. And now, on the back side of that paper, okay, so the question is this an identity? No, it's not an identity. It looked like it was going to be the same thing, right? But it wasn't the same thing. See, when you try to simplify, see, this is difference of squares, x minus 3, x plus 3, difference of squares, x minus 3, x plus 3. Then you cancel out the x minus 3's. You end up with x plus 3 minus x plus 3. And when you distribute, you end up with negative x and negative 3. So everything cancels out. So 0 is not equal to 6, so it's not an identity. Okay. Okay, questions about this problem? No? Okay, now go ahead and try the problem at the bottom, proving identities. And I want you to have a good feeling about proving. Let's see if you can get this one, okay? So go ahead and try. Once you multiply by the LCD, whatever is missing, to get the LCD is sine of x, cosine of x. Then, do you identify something here that you can simplify? Do any of you know what this is? On your formula chart? What is this equals to? That is just 1. So that is just 1. And now since I need to write secant first and then cosecant, I can just flip sine cosine. So I can just have it as cosine x first and then sine x second. And that when you like separate it, it would be 1 over cosine of x, 1 over sine of x, which is secant of x, cosecant of x. And if anything, just try not to move the right side, just leave it the way it is to see if you can let it equal to the right side. So it is an identity. Okay, we proved that left side equals to the right side. Any questions about this? So far so good? Okay. So now I'm going to ask you out of the second to the last and the last one. Any question about those two? This problem, we have 1 minus sine of x and 1 plus sine of x. This is divided by sine square of x. It's supposed to be equals to cotangent square of x. Okay, so the idea from Brenda of multiplying those two using FOIL method on the previous problems, when you multiply that, that's going to be 1 times 1 is 1. This is plus sine of x minus sine of x, and the last is minus sine squared of x. See, the sine of x and the negative sine of x cancel each other. You're going to have 1 minus sine squared of x. And if you look at the formula chart, what is 1 minus sine squared of x? Cosine over sine. That is cotangent. And that is equals to the right side. So it is an identity. Okay? So the review, as you walk out, I'll give you the review. Please work on that review for homework. Please take this, and this was to be the quiz. Let's see how confident you feel about this. We did like the most challenging problems, okay? So the review. It's pretty simple, okay? So I hope that you can do this and you can do it like super quickly.
I'm not gonna be here tomorrow, Friday.
So then be ready for the quiz on Monday after school, okay? I'm not after school, tomorrow morning, conference with another teacher. But, it's better for you to come tomorrow morning? Okay. I might know the person here. Have a wonderful day, guys. Did I see those later? Oh, the one at Trig. Yes, it was good. I like
Seventh
it.
period though. I know.
Did you go seventh period also?
Yeah.
Were you the ones who were making all this noise in the back?
Here was me in the top part,
Uh-huh.
and like the people to the right and the ones who got
Yes, the people to the back, right, were the ones who were like talking. I was like, that's not right. But he did a great job. You and the girl, so you were enjoying the whole view. And when the girl was like this, and you were like, ooh, I didn't like the Albert. It was a good play, I liked it.
They were? They were doing stuff? Not crazy. I go to my class.